Ready, sir? Hi, everyone. Today we are going to discuss about ion exchange method or demineralization method. Okay, this is an example for external treatment. Definition, what's the definition for external treatment definition? That is a removal of impurities or salts from boiler feed water before feeding into the boiler is called as external treatment. We are removing the salts, hardness causing salts from boiler feed water. What is the meaning of boiler feed water? Water fed into the boiler is called as boiler feed water. Before feeding into the boiler, we are removing the hardness causing salt. That is called as external treatment. So, this is the definition for external treatment. Okay, then afterwards we are going to study in detail about the ion exchange process. One of the external method is external treatment method is ion exchange method, ion exchange method or demineralization method. Ion exchange method or demineralization method. Okay, so first you must write here, this is the definition you can write. That is, here we are going to use the resin we are going to use. So first of all, we can give the introduction. We will write this side what you have to write. First we have to write introduction. So in the introduction, what we have to give is what we are using. Here we are using resins. Okay, in zeolite method, we are using zeolite bed is used, okay, to exchange the ions. Here, what is the important use compared to zeolite method? In zeolite method, only cations are removed. Here, all kinds of cations or anions, everything is removed. All kinds of ions, any ion is present, automatically it is removed. That is the advantage of this method. So, introduction, first what you have to write, that is all ions, the cations and anions are removed. Both cation and anions are removed by using cation exchange resin bed and anion exchange resin bed. This is your introduction. Next, we have to write about resin. What is resin? Resins are cross-linked, insoluble organic polymers. Okay, they are actually organic polymers, and here we are using two kinds of resin. One is cation exchange resin, cation exchange resin, and another one is what we are going to use is anion exchange resin. Cation exchange resin, anion exchange resin we are using. Cation exchange resin, how it is represented? Cation exchange resin is represented as RH2. Anion exchange resin is represented as R dash OH twice, because already we have used R. Okay, this R is a long chain polymer. This is a cross-linked organic polymer, and moreover it is a long chain polymer. Instead of writing full alkyl group, we are writing as R alone. Okay, so next one, what you have to write is example for cation exchange resin. So how you are writing cation exchange resin example? What is the example for cation exchange resin? That is, we are having sulfonated coals. Sulfonated coal is an example for cation exchange resin. Otherwise, if you are having any alkyl group with sulfonic acid group RSO3H, then this also acts as a cation exchange resin. Okay. So, commercially how it is called as means Dovax 50. Commercially how it is called in the trademark, how it is represented means DOVAX 50. This is example for cation exchange resin. For anion exchange resin, how it is represented? R dash OH twice. Okay, so here the example for this anion exchange resin is urea formaldehyde, amines, and in general you can write it as RNH2. In commercially available is DOVAX 3. RNH2 commercially available, how it is called as DOVAX. So this is the example. This is how you have to write the resin part. Resins are long chain, cross-linked organic polymer, and they are insoluble in water also. Okay, so there are 4 points you have to write. So resin means they are insoluble, okay, cross-linked, long chain, organic polymer. So this is the definition for resin. Okay, resins means they are insoluble, cross-linked, long chain, organic polymers. Types of resin, there are 2 types of resin. One is cation exchange resin, another one is anion exchange resin. How it is represented? Cation exchange resin is represented as RH2, anion exchange resin is represented as R dash OH twice. Example for cation exchange resin is sulfonated coal and RSO3H. Commercially available as cation exchange resin is DOVAX 50, and anion exchange resin example is urea formaldehyde, amines, or sometimes you can write it as RNH2, and commercially available is DOVAX 3. Okay, so this is something about resins. Okay, so first of all we are writing introduction. In introduction what we have to say? All cations and anions are removed in this process. That is the introduction you can write. Then you have to write explanation about the resin. We are writing about the resin. Okay. Then the next one what we are going to discuss is how the resins are prepared. Preparation of this resin we are going to discuss. So preparation of resins means resins are prepared by the copolymerization of styrene and divinyl benzene. Copolymerization of styrene and divinyl benzene. What is the structure of styrene? Styrene structure, this is the structure of styrene. You can write, this is your benzene ring, and at the top you can write your vinyl group CH double bond CH2. So this is known as styrene. This is known as styrene. Then the next one, only one vinyl group is present in the benzene ring means that is called as styrene. Suppose 2 vinyl group is present. One vinyl group is present at the top and to the para position. Another vinyl group is present means that is called as divinyl benzene CH double bond CH2. This is called as divinyl benzene. So, these 2 polymers undergo copolymerization process and it forms a polymer. Okay. So, the resultant polymer when it is treated with acid, the resultant polymer is treated with acid means it forms cation exchange resin. And if the resultant polymer is passed with base like ammonium chloride means it forms the anion exchange resin. Okay, so this is how you have to write, explain the resin. So explain the resin. Under explanation, first what we are writing in the resin, what is resin? Definition we are writing. Okay, then types we are writing. Cation exchange resin, anion exchange resin. Next, what we are writing? Example. Example for cation exchange resin as well as anion exchange resin we are writing. Next, what we have to write? Preparation of the resin. Okay, preparation of the resin we are writing. Okay, so this is how all the points we have to write it for resin. Now only we have to draw the diagram of ion exchange process or demineralization process. I'll draw the diagram now. We have a two bed. One is cation exchange resin bed. Another one is anion exchange resin bed. We will see. First you have to take, this is first cylindrical part, cylinder 1, and same way you can draw the diagram of another cylinder. This is cylinder 2. This is a cation exchange bed. One is anion exchange bed, another one is cation exchange bed. So to differentiate, I am putting here single line. So this is, what is this? This is cation exchange resin bed. Okay, and this is anion exchange resin bed. So to differentiate, I'll write like this. So this one is anion exchange resin bed. Okay, so here what we are having afterwards at the side, we are having the regenerative column. We are having regenerative column like this. Here we have a tab, we can close it. So this is your regenerative column. Here we have to take the solution of HCl. Okay, in the same way, in anion exchange bed also we are having regenerated column. Here what we have to take? NaOH. NaOH is used. Okay. So what we are passing? Raw water, otherwise hard water, which contains both cations, hardness causing cation as well as hardness causing anions. So here we are passing hard water. So this contains cation as well as anions. Hardness causing cations, example, you can write Ca2 plus and Mg2 plus. This is hardness causing cation. Positively charged ions, hardness causing cation. Hardness causing cation. Hardness causing anion, which one you can write? Cl minus you can write, otherwise a sulfate anion, carbonate anion, anything you can write. Here I will write two examples. So this one is hardness causing anion. Where these two are present? They are present in the hard water. Okay. So this hard water we are passing in the cylinder 1, and then afterwards here we are having one outlet. So this outlet has to join for the inlet of the second cylinder. This is the inlet for the second cylinder. So for this I will write what's the outlet here? We are having the outlet here like this. Okay. So this water I will take, hard water. So I will write with the, so it contains hardness causing salts. Okay. Then afterwards, once it enter into the cation exchange resin bed, what will happen afterwards? Cations are absorbed. Then that cation free water enter into the cylinder here. Here also we are having water. And afterwards, after passing the anion exchange resin bed, which water is formed? That water is called as demineralized water. which is free from all types of ions. Okay, so this is the neat diagram of the ion exchange method. Okay, so first what you have to, I will explain once again the diagram. First you have to draw the cylinder. This is cylinder 1 and this is cylinder 2. So this is what is the cylinder, how it is represented? This is represented as RH2, cation exchange cylinder. So it is represented as RH2. And what is this one? This is represented as anion exchange cylinder. It is represented as ROH twice. Okay, based on this only we have to write the equations. So once again, this is cylinder 1, cylinder 2. So what we have to write next after resin explanation, you have to draw the diagram. After diagram, what we have to write? Principle. What is the principle here? That is raw water. When the hard water enter into the cation exchange resin bed, this resin exchanges the Ca2 plus ion and Mg2 plus ion. Then the cation free water, it enter into the anion exchange resin. The anions are exchanged. That is the principle. Okay. Then afterwards, what you can write? Working. Diagram is over. Next side heading, you can write it as working. That is, first we are passing into the bed of cation exchange cylinder. During that time, all the cations are exchanged, and during the anion exchange resin bed, all the anions are exchanged. Then the next one, what you have to write? Reactions. What are the reactions? Reactions only important. See, first of all, what we are having? Cation exchange resin bed we are having, isn't it? So here we can write the equation. So what is the equation? In the cation exchange bed, what we are having? We are having RH2. Okay, so here I will write the equation. RH2, example, which salt is present? CaCl2, I will take it as an example. Okay, so where this CaCl2 is present? It is present in the hard water. Okay, so this is nothing but hardness causing salt. Otherwise, where it is present? It is present in the calcium chloride. Clear? So then the next is, what will happen? Exchange of ions takes place. Clear? Calcium is also 2 plus ion and chloride monovalent ion. What will happen? It forms RCa plus 2HCl. In the same way, we can write it for magnesium chloride also. What we will have? RH2 plus MgCl2. If we take, what will happen? RMg plus 2HCl. Listen, where this RCa and RMg will be present? It is present in the cation exchange resin bed itself. Clear? So what will happen? The remaining cation free water. What is this water is called as? This water is cation free water. You can write it as here also, cation. Now all the hardness causing ions are removed. So this is cation free water. So this cation free water is entered into the anion exchange resin bed. So what will happen here? Here the anions, that is, there is no Ca2 plus, there is no Mg2 plus. So which ions now we are having? Chloride ion alone. It is passed into anion exchange resin bed. So anion resin, how it is represented as? R dash OH twice. So this R dash OH twice reacts with HCl. So here I am writing HCl, and what it gives? It gives R dash Cl2 plus H2O. Clear? Balance this equation. So here 2H2O, and also here you can write it as 2. Now it is balanced. I have written only chloride ions. Suppose if you write sulfate anions, that is like calcium sulfate or magnesium sulfate. For calcium sulfate alone, I will write the equation. What will happen? For that cation exchange, how it is represented? That is RH2. What I am having? Calcium sulfate is your hardness causing salt. During that time, what is the reaction takes place? It gives RCa plus H2SO4. Self-balanced equation, no need to balance. Okay, so then next, suppose if the sulfuric acid is present here, what will be the equation here? R dash OH twice plus H2SO4, and it gives R dash SO4 plus H2O. Here also you can write it as 2H2O. So what is this water is called as? This is our product. The water is called as demineralized water or deionized water. Deionized water or demineralized water. Where it comes? Here it comes. The water coming out here, you know, this water, outlet water is called as demineralized water or demineralized water or deionized water. Clear for all? So, this is the process of ion exchange method. So, once the resin is exhausted, now there is no resin to replace H plus ion and OH minus ion. During that time, what will happen? We have to write the regeneration method. What is this? We have to regenerate. So, the next step is regeneration. On prolonged use, when this regeneration takes place, on prolonged use, all the resins are exhausted. So, during that time only regeneration takes place. Simple you can write. How you can write regeneration? Cation exchange bed is regenerated by HCl. Anion exchange resin bed is regenerated by NaOH. For regeneration also you have to write the equation. If you write the reactions here, then you can write the regeneration step also very easily. How you can write? That is here, now the cation exchange resin bed is fully, how it is converted? It is converted into RCa or RMG. Now the bed does not have any RH2. Now the bed is having only RCa or RMG. So with this, what we are adding? We are adding HCl. So if we add HCl, what is the product? That is, we are getting RH2 plus CaCl2. Similarly, RH2 plus MgCl2. Balance this means here you can put 2, 2. So, this is cation exchange bed regeneration. Similarly, anion exchange bed, how it is regenerated? How the anion exchange resin bed has now? They have only RCl2 or R-SO4. So, in the anion exchange resin bed, what is the reaction? That is, it is converted into R-Cl2. So, it is reacted with which reagent is used? NaOH is used to regenerate. So, here it gives means what will happen? R-OH twice plus NaCl. Balance this means 2. Here also you can put 2. Is it clear? Otherwise, for this one, if you want to write R-SO4 plus 2 NaOH, it gives R-OH twice plus Na2SO4 here also. So, this is how regeneration reaction takes place. Clear? So, this is ion exchange method or regeneration, demineralization method. Regeneration step is over. So, next one what we have to say is advantages. Another one is disadvantage. advantage. Another one is what we are going to discuss is disadvantages. Okay, advantage we are having 3 points. Advantage we are having 3 points. First thing is the outcome water, that is the outlet. What is the product we are getting is deionized water. Okay, that water contains the hardness is very least. That is the hardness of 1 to 2 ppm water is produced. Okay. Then the next thing is all cations, both the cations as well as anions are removed. Similarly, acidic water as well as alkaline water, any water can be treated. Acidic water or alkaline water can be treated. Is it clear? Then the next one is both the cations and anions are removed. Both cations and anions are removed. We are removing. Okay. Similarly, disadvantage. We can write disadvantage 3 points. First one is expensive. This method is expensive. Expensive. Why this method is expensive means resins. Here we are using, polymer, that is costly. Then the next one is water containing iron and manganese cannot be used. If the water contains iron and manganese, such a water cannot be used because they form a complex with the resin. So we cannot use it. Similarly, turbid water cannot be used because it clogs the resin, otherwise it blocks the resin. So these are the 3 disadvantages. Similarly, advantages we can use this also in high pressure boilers also we can use. So many advantages are there, that also you can include. Okay, so this is the something about ion exchange method. In short, once again I will repeat. First of all, what you have to write? Introduction. What is the introduction? Both cations and anions are removed by using ion exchange method or demineralization method. Next, what you have to write? What is resin? Explain the resin. What is resin? Resins are insoluble cross-linked organic polymer. Okay. Then next types: cation exchange resin, anion exchange resin. Example, how it is prepared. That is cation exchange resin bed is represented as RH2, anion exchange resin bed is represented as ROH twice. Example for that is cation exchange resin bed, sulfonated coals. Here anion exchange bed means urea formaldehyde preparation. They are prepared by the copolymerization of styrene and divinyl benzene, and the resultant polymer, when we treated with acid, it forms the cation exchange resin, and when it is the resultant polymer is treated with a base, then it forms the anion exchange resin. This is the diagram. We are having the cylinder 1 and cylinder 2. This is cation exchange bed. It is represented as RH2. This is anion exchange resin bed. This is represented as R-OH twice. So here, first of all, what we have to do? We are passing the the diagram. After that, the principle simple exchange, ion exchange process takes place. Working, what will happen? That is, hard water is entered into the cylinder 1 where all the cations are exchanged by the H plus ions. So what will happen? The cation free water is entered into the anion exchange bed there where all the anions are exchanged by the OH minus ions present in the or the cation exchange resin. Therefore, the reaction is given here. This is the reaction takes place in cation exchange resin bed, and this is the reaction takes place in the anion exchange resin bed. On prolonged use, what will happen? Regeneration has to be takes place. It is exhausted. So that is next step is regeneration step. So we have to regenerate. Cation exchange resin bed is regenerated by HCl. Anion exchange resin bed is regenerated by NaOH. For that also you can write 2 equation. or 1 equation you can write. Then afterwards what you have to write? Advantages. Advantages 3 points, disadvantages 3 points. Advantages nothing but it is the demineralized water has very low hardness of 1 to 2 ppm. Acidic water and alkaline water can be treated by this method, and both cations and anions are removed. Otherwise, we can use this water in high pressure boilers also. And disadvantages, if you are taking, the method is expensive because of the resin. Then water containing iron and manganese cannot be treated because it may form a complex with the resin. Turbid water cannot be treated because they may clog the resin. That's all. Thank you.